So hi guys, I hope you are having a good day. This is going to be section 3.3 and we are officially going to be getting into conics. So conics are things like parabolas, ellipses, hyperbolas, and circles as well. So throughout this course of this semester, we have studied functions, and functions have passed the vertical line test. But these conics do not pass the vertical line test because obviously a circle will not pass the vertical line test, an oval will not pass the vertical line test, and parabolas that go side to side also will not pass the vertical line test. So again, as you can see here, these are conics and that's what makes it different. In this section though, we are going to be focusing on parabolas, and in particular, quadratic equations, all right? And in this section, we're going to be looking at parabolas that open upwards and open downwards, all right? So a quadratic function, by definition, is a function that is defined by a polynomial expression. Now, I want to make one note here that this is going to be of degree 2, so that's where we are coming into play, okay? So we typically think of a quadratic equation as being expressed in standard form from our previous Algebra 2 class as looking like this. However, this is kind of a misleader. In actuality, though, the standard form looks like this, where f of x then equals x minus h squared plus k. Now, this is something special here because in this form, it goes ahead and it tells us the vertex. Now, the vertex we talked about in the first exam, and that is either the lowest point or the highest point on the parabola, depending on which way it opens. So this formula then is HK. So notice here, it changes the sign on the inside of parentheses, but out here, it's kept the same. Okay? Now, as you recall, if A is positive, that means the graph opens upwards. It's smiling at you. Whereas if it's negative, it's opening downwards and is frowning at you. All right, so here are some nice things about parabolas. Now, if we look here, I have here the completing the square procedure for you. I will go ahead, I will upload a video here very soon. This is my first video. I'm doing a little out of order. I've spent the last 4 hours trying to figure out how to use this new program. So, woo, I figured it out, but it took way too long, but I think it'll be worth it. So here's the steps for completing the square. All right. Now, here are some problems. I will go ahead and I will do these in the other video, so I do promise you will see those. All right, so let's look here. Our first equation here is f of x equals x squared plus 8x minus 6. So we'll go ahead and write this in standard form. Now, as we look at it here, this is the standard form that we saw in our Algebra 2 class, but now we are more sophisticated, so we can start elaborating even further. So if I bump down here, I do apologize. There's something down here that makes it move. I'm not quite sure what that is. So based on our completing the square procedure, I have here f of x equals, okay, my function x squared plus 8x minus 6. So like we did in the completing the square video, I'm going to add 6 over to the other side to give me then f of x plus 6 equals then x squared plus 8x. Now, just like we did for typical completing the square, we're going to go ahead and we're going to do the aside. Now, when we do the aside, as you recall, that is going to be b over 2, square it. So that's going to be then the coefficient of x divided by 2 squared, which will then be 4 squared, which is then 16. So we're going to go ahead then take then this magic number and we are going to add it to both sides of the equation. So f of x then plus 6 plus 16 equals then x squared plus 8x plus 16. Combining like terms on the right, excuse me, that's the left, just kidding. And then factoring then on the right. Okay. Now, at this point in the completing the square video, we were able to add these terms together over here and then do extraction of roots to solve from there. Well, we're not going to do that here. Instead, I had mentioned in that video that we are going to be using this to write it in a different form. All right, and that's what we're going to be doing here. So to get it into completely then standard form, we're going to go ahead and we are going to subtract the 22 over to the other side to give me then x plus 4 squared minus then 22. This then is in standard form. Okay, and we can then use that then to get some very valuable information. Like in part B, it asks us for the vertex and the x and y intercepts of the graph. Well, as I take a look at this, all right, the vertex is given to me exactly through the equation, all right? It is hk. Now remember, this right here, this 4, is your h. But to be in standard form, you need to change the sign. So you're going to change the sign there and make it into a -4. And then the k sign stays correct. So that's going to be then a -22. So my vertex then is at -4, -22. Okay? Now, working then from there, okay, we're going to go ahead and get the x and the y intercepts. Now, this is nice because the x and y intercepts are exactly what you thought they were when we graphed a line and when we graphed random parabolas and that fun deal. So, let's start off with a fun one. Let's start off with the y-intercept. As you recall, to find the y-intercept, we're going to go ahead, we're going to set x equals 0 and solve for y. Now, my personal preference is I like to go ahead and to use the original expression, the original function, x squared plus 8x minus 6 to find my y-intercept. So that's going to be then f of 0, which will then be 0 squared plus 8 times 0 minus 6, which is -6. So my y-intercept then is a 0.0, -6. Now, in case you forgot, you can pause this video and like in class and go back and look over things if you do have a question. All right? And then like before, to find the x-intercept, we're going to go ahead, we're going to set then y equal to 0. Now, I personally then like to use the, I like to use the standard form to find the x-intercept only because it is a little easier to use extraction of roots than on this problem. So this then gives me 22 equals x plus 4 squared. Taking then the square root of both sides, this then gives me plus or minus the square root of 22 equals then x plus 4. And subtracting that over then, this gives me that x equals -4 plus or minus the square root of 22. So to get those out then to be approximate, -4 plus square root of 22, that's what I want. There we go. Just to make it a little bit easier to plot, that's then 0.69, and the other point's a -8.69. So right now I have 1, 2, 3, 4 points. So let's go ahead then and plot these on the graph. So we said my vertex was the point -4, -22. So -4, -22, that's going to be down there. Okay, I'm sorry, I don't know why that keeps popping up. Let's erase that, make that a little bit cleaner. Come on. Oh, it's got the eraser. Oh, silly me. Okay, so there's -4, -22. I got then my 2 x-intercepts, plot those points then. And then my y-intercept we said was 0, -6. So there's my points. All right. We know here by looking at the original equation that that leading coefficient is positive, so the graph is going to open upwards. The graph does open upwards. We can then go ahead and play everybody's favorite game of connect the dots. Do. All right, and there we go. Now, for part D then, we asked to find the domain and the range. Now the domain, this is a quadratic equation, so we know it's going to be from -infinity to infinity. And then looking then at the range, all right, it's going to include that vertex, which is a -2, 22, all the way then up to infinity. So that looks fantastic then. All right. Let's go ahead then. Let's have some fun, okay? I want to now take a look at x squared plus 9x. Part A then asks me to go ahead and to write this in standard form. So as you take a look at this, the first thing you notice is that it does not have a c term. And that's perfectly fine. That's not a problem at all. We can still work it totally fine. So just like before, we're going to go ahead. F of x equals x squared plus 9x. There's no constant term to move over, so we're good from there. Whoops, moving things around a little bit too much. Let's go ahead then. Let's start working on our side. Again, that's going to be b over 2. We're going to go ahead and square that. Now, mind you, again, b is the coefficient of x. And since 9 is not evenly divisible by 2, we're going to go ahead, square top and square bottom to give me then 81 over 4. Adding then that magic number to both sides. Factoring then the right-hand side, okay? Again, remember how we did that in the other video, okay? Oops, I forgot my 81 over 4, my bad. And then move that 81 over 4 over to the other side. So in standard form then, I have x plus 9 half squared minus then 81 over 4. This again is my standard form. Fantastic, fantastic. All right, and again, the benefit of doing it that way is we can go ahead then and we can use this to tell us about the vertex and all that fun stuff. So part B, ask us for the vertex. Well, my vertex then, whoops, go back over to pen. Again, still getting used to this. My vertex is going to be, okay, on the inside of my parentheses, we're going to go ahead, we're going to change that sign. So that's going to be the x-coord of my vertex, so a negative 9 halves. And then my y-intercept, or my y-coord of my vertex, is the outside term here. And again, we do not change that sign, so that's going to be then a negative 81 over 4. So there then will be my vertex. Now, as we then take a look one step further, okay, we're going to go ahead and find our x and y intercepts. So this will be pretty nice then. To find the x-intercept, again, we're going to go ahead. We're going to set y equal to 0. All right. So this is pretty nice then, all right, for us. As we take a look at this then, I end up with 0 equals x squared plus 9x, solving a nice quadratic equation here. Now this one we've done about 14 billion times already this semester. All right, so I got my two x-intercepts of 0 and negative 9. And then finding my y-intercepts, that's just going to be then f of 0, which will then be 0 squared plus 9 times 0, which is 0. So that's no surprise either that the y-intercept will be the point 0, 0. Now, since I only have 3 points, if you would like, you can always add more points to your graph. Because again, the more points you have, the more accurate your graph actually is. Whoop, it doesn't like me right now. Okay, I got that. And then negative 9 halves is a negative 4.5. 81 over 4 is about 20.25. So that's like way down there. So it's like right about there. All right, now that looks pretty good. So if you want more points, you can. I'm so sorry about that. Please don't hate me terribly. Playing then everybody's favorite game of connect the dots. And again, if you need to pause at any point and go back something, please feel free to go ahead, rewind the video. Now next then we're asked to go ahead, find the domain and the range. Again, the domain is from negative infinity to infinity. And then my range, remember, we're including that y-coordinate of the vertex. So that's going to be then a negative 81 over 4 to infinity. So that's why it gets the bracket on that one. Fantastic, fantastic. Okay. All right. Now, as we take a look then here at the next one, as we approach this problem, the first thing we notice is that the leading coefficient, the A, is no longer a 1, but rather it is a 2. Now, when we did the completing the square video, we said, okay, we need to make sure that leading coefficient is a positive 1. Excuse me. So what we did then was go ahead and divide everything through by that 2. Well, unfortunately for us, that technique is not going to work here. So to play it then on the safe side, what we want to go ahead and do is we're going to manipulate this ever so slightly, okay? The very first thing that we'll go ahead and do is we're going to factor out a 2 from only the x squared and the 12x. So the 2x squared and the 12x, factor out a 2 to make it sure then that that leading coefficient is a positive 1. We're going to go ahead, factor, or move over, not factor, good lord, subtract over 10 over to the other side. Okay? Now, we need to be very, very, very careful here. We're going to go ahead, okay? We are going to try here to take a look at the inside here. So just like before, we're going to go ahead, we are going to do the aside. So we're going to take then that b term, divide it by 2, and square it, which then gives me 3 squared, which is 9. So when we add then the 9 to that side of the equation, I want you to notice that it's going to go on the inside of those parentheses so that we can factor that portion, okay? So that's going to be the interesting part. So when we factor then that right-hand side, this goes then 2 times x minus 3 squared. So that makes perfect sense. However, the issue is we're not really adding 9 to both sides. In actuality, we're adding 9 times the 2, so we're really adding 18 to both sides. So when I add that 9, I'm really adding 18, so I got to add then the 18 to both sides. So this then gives me f of x plus 8 equals then 2 times x minus 3 squared. And then to finish off in standard form, we're going to go ahead and subtract over the 8 to the other side. So now this then is officially in standard form. So then when we go ahead to set up our vertex, okay, random periods in the process here, there's no buttons down here at the bottom, so I don't know what I keep hitting to add things in, so I apologize. So then when we go ahead and get the vertex then is going to be to change the sign of the x term and then bring down the negative 8. So there is our vertex. So that's right there. Woo-hoo. All right, so just like before, we're going to go ahead then. We are now going to go ahead and get our x and y intercepts. So as we take a look then at this, to get my x and y intercepts, okay, to find my y-intercepts, I'm going to go ahead, I'm going to set x equal to 0. So f of 0 then, that's going to be 2 times 0 squared plus 12 times 0 plus 10. Well, that's nice, that's just 10. So my x or y-intercept is the point then 0, 10. Now taking it then one step further, to find the x-intercept, I'm going to go ahead, bump it yet again. It's almost like the projector. Every time you kick it, it works. All right, I'm going to use then that standard form. So that was then 2 times x minus 3 squared minus then the 8. Add the 8 then over to the other side. Divide by 2. Take the square root of both sides. Then gives you plus or minus 2 equals x minus 3. Solving then those two equations, x minus 3 equals 2, x minus 3 equals a negative 2. Add 3 over to the other side, I get x equals 5, and x equals 1. So there's my 2 x-intercepts. Again, if you want to get more points, you can go ahead and find those by plugging them into the equation. Okay. So then sketching our graph, we have our x-intercepts of 1 and 5. Something's not quite right here. It should be -1 and 5. Why am I off? What's going on? Let's pause it for a second. Alright, so I figured out what's going on here. I made a sign mistake. So you're probably wondering why it factored from x squared plus 3x plus 9, x minus 3. It should be x plus 3, and that makes a whole lot more sense, which will then go ahead and change our vertex to be -3, -8. And then when we go to solve down here, just changes the signs ever so slightly. So my apologies on that. Okay, so plus 3, plus 3. So that means then that'll be a -1, and this will then be a -5. So now that looks much, much, much better. Losing my mind, story of my life. All right, so watch those signs. You think I say it for you, I really say it for me. All right, so now we can go ahead, plot then those points. I got -1, I got -5, and then we said our vertex was -3, -8, which is then right down here. Okay, and we have our y-intercept, which we said was 0.6, if my memory is 0.10, just kidding. Okay, I think 0.6 was the last one. I think we circled too much. That's what causes it to randomly move. All right, so now we got the points. It is positive, so it should be opening upwards. That A is positive. So we can go ahead again, play everybody's favorite game of connect the dots. All right, and there we go. Okay, nice and smooth. Again, please make sure to make it into a U as opposed to into a V shape. So please be mindful of that. All right, so last thing then for this problem is we're asked to go ahead, find the domain and the range. So to find then the domain, of course, the domain is going to be all real numbers from -infinity to infinity. And then my range is going to be, including our vertex, the lowest point on the graph, which is the minimum, from -8 then all the way up to positive infinity. Okay? All right, fantastic. So now let's take a look then at the next example here, okay? Well, the next thing we'll talk about is, as I started to mention, the maximum or the minimum. So if a graph opens upwards, it has a minimum value. That minimum value takes place at the vertex. And in a similar fashion, if the graph opens downwards, it's going to have a maximum value at the vertex. So the maximum and minimum values of a parabola always will occur at the vertex. So let's skip ahead then. Let's look then at the very last page of the notes. Now I spaced mine out a little bit, so I think it's like page 6 or 7 here. So let's go ahead then. Let's find the maximum or the minimum values for each of these quadratic functions. Okay? Now, when you look back, you can either put it in the standard form to find the vertex, or you can go ahead and use these values, all right? So to find the vertex, to find the x-coordinate of the vertex, we can go ahead and use the formula. X equals then a -b over 2a. So watch your signs here. This negative is part of the formula, so that's going to be then a -5 over then 2 times 1, which is then 5/2. So that's the x-coordinate of the vertex. So the maximum or minimum, that is your y values for those functions. Okay, so those are your y values. This is your x. So to find then your y, you're going to stop bumping whatever you're bumping. All right, you're going to plug that 5/2 into the function. So you're going to be looking then at 5/2 squared minus then 5 times 5/2. Well, 5/2 squared, square top, square bottom. Fraction multiplication is multiplying going straight across. I need then a common denominator to subtract those. So this then gives me my value here, my maximum or my minimum, is going to be then a -25 over 4. Now, since that coefficient of x squared is a +1, that means then that the graph is going to open upwards. which means then that this is in fact going to be a minimum. If I can spell it, there we go. All right, so that in fact is going to be a minimum. Very good. Let's go ahead. Let's take a look then at the next one. So in this particular example then, I have f of x equals 2x squared plus 8x plus 11. So again, we can put it in the standard form, or we can have some fun and take a look at this and use that formula. So again, to get the x coordinate, the maximum or the minimum occurs at the vertex. So the x coordinate of the vertex is given by the equation negative b over 2a. Now plug it in then. Again, this is the same a, b, and c that you see in the quadratic equation. So that means then the x coordinate of my vertex occurs at x equals negative 2. But remember, we need the maximum or the minimum. We're not referring to the x value, but rather the y value. So we're going to go ahead, plug this then into that equation to figure out then what that value is going to be. So negative 2 squared is a positive 4, 4 times 2 is 8, minus then 16 plus 11, 19 minus 6 is 3. So there's either my maximum or minimum. Again, since that coefficient of x squared is positive, that means then this is in fact going to be a minimum, because again, a is positive, which means then that the graph opens upwards, right? Which means the graph is smiling at you. So it's going to be a minimum. Fantastic. All right. So let's go ahead then. Let's trickle on back here and let's do a few more practice problems, putting this then into standard form. So let's back up the phone here. All right, we're looking for the equation negative 4x, there it is, minus 12x plus 1. So as we look at that a is negative, which means the graph opens down. So that's always a good thing to know. So we know the graph should look something like this when we are done. Okay, so express it then in standard form. So first thing I'm going to do is move that constant term over to the other side. Okay, x squared minus 12x. Now remember, we want that coefficient of x squared to be a positive 1. So to take care of that then, we're going to go ahead and we're going to factor out that negative 4. So leave me then negative 4 times then x squared plus 3x. Now, just like before, we're going to go ahead and we're going to create an aside. And again, that's going to be b over 2. We're going to go ahead and square that. This then gives me 3 over 2 squared, which then gives me 9 over 4. So there is going to be my magic number. Now remember, since we factored out that negative 4, this goes on the inside of those parentheses, okay? So we're really not adding 9/4 to both sides, but we're taking 9/4 times that negative 4, which is a negative 9. So we're really adding not 9/4, but negative 9 to both sides, okay? Now, cleaning up then that left-hand side, that's going to be then f of x minus 10 equals then, well, we have that negative 4. And then, of course, we can go ahead and we can factor that inside. And again, watch the completing the square video for the explanation of how that is factored. And moving then finally that 10 over to the other side, we are now officially in standard form, okay? And once we have it in standard form, okay, we say, does the graph have a maximum or minimum value? Well, as we looked at it, we said from before that the graph is opening downwards. So since it's opening downwards, the graph has a maximum value, okay? It has a maximum value. That maximum value then is going to be the y-coordinate of your vertex. So in this case, the maximum value that, will just be the 10. Okay. Find then the vertex. Oh, that's nice and easy. Again, change that sign on that x. The y then will remain the same. So that's going to be then a negative 3/2 10. All right. Now from there then, we're asked to find the domain and the range of the graph. Well, the domain, again, it is a quadratic equation, so that's going to be then from negative infinity to infinity. Since the graph opens downward, it's going to be then from negative infinity all the way up to its maximum value, which is 10. Now, before we graph it, let's go ahead, let's find then some more additional points to work with. So I'm going to go ahead, of course you know I'm going to pick the x and y intercepts. We all know how much I love 0. All right, so in taking then a look at this, finding then my y-intercept, of course we're going to go ahead then and set x equal to 0. So f of 0 then is going to be negative 4, sorry, take a pencil there a little bit too much, negative 4 times 0 squared minus 12 times 0 plus 1, which is 1, so my y-intercept is the point 0, 1. Okay. Getting then my x-intercepts. Okay. I'm going to go ahead, setting this then equal to 0, which one will be a little bit easier to work with. Oh, let's go ahead. Let's use the original one. So 0 then equals negative 4x squared minus 12x plus 1. Which will be fun then to use this then, solving using the quadratic formula. Okay, everybody's good old friend. Okay. So that'll be then 12 plus or minus square root of 12 squared, negative 12 squared, I know, minus 4 times a negative 4 times a positive 1, all over then 2 times a negative 4, which will then be, oops, keep the pen back here, 12 plus or minus then square root of 160 over a negative 8, which is then 12 plus or minus 4 square roots of 10 over a negative 8, which will reduce then down, everything's divisible by 4, to 3 plus or minus square root of 10 over a negative 2, which is approximately 3.08 and negative 0.08. All right, so now I got plenty of points so we can go ahead and sketch this out. So, moving things around all over the place, okay. 0, 1, come on, you can do it. 0, 1 will be right there. My vertex, which is negative 1.5, 10, which goes up here. Okay. I have then my oh, silly me, I dropped the negative sign. That should be a negative 0.38. Oh boy, story of my life. Watch those signs. Down there, and about there. So my graph is just a touch off. Move that up just a bit. Okay, and that also means that this should be a negative. I typed in a positive too instead of a negative. Watch the signs. Okay. All right, so mine's a little bit off here, okay? But you can still see we are gonna have that nice parabola-ish shape. That's why it looks so bad. Good Lord, am I having a rough day? It's because it's Friday and 10 o'clock at night, because I'm still working on this. All right, so negative 1.5, that's right there. 1.8, negative 3. Now it looks much better. And there's my parabola. Oh, good Lord. My gosh, I can't plot today. Negative 0.8 is about there. Now it looks much better. Oh, learn your numbers, Miss Daly. Learn your numbers. Okay, but yeah, negative 0.8, not 0.08, excuse me, not 0.8. I'm losing my mind. Ugh. All right, that one was a little rough on me. Okay. But let's go ahead then. We got one more example in this section. And again, if you have questions, feel free to go ahead and email me. All right, I will be checking my email today. Okay. All right, so the first thing we notice here is that life is happy, A is equal to 1, which means then the graph is going to open upwards. So right off the bat, we know that we are going to have a minimum. So that is good news for us to hear. So let's go ahead then, let's express this then in standard form. So first thing I'm going to do is go ahead and move that constant term over to the other side. Okay. Work then on my aside. Now remember, the aside is b over 2 squared. So that's going to be then a negative 4 over 2 squared, which is a negative 2 squared, which is a positive 4. So when I then add 4 to both sides, notice what happens here. Those 4's are going to go ahead, they're going to cancel out, and we end up back with exactly what we started with. That's because this x squared minus 4x plus 4 is already a perfect square. So that factors very nice then in the x minus 2 quantity squared. So the reason I bring this to your attention is notice we don't have a constant term on the outside here being added together. So that means then when I go to talk about my vertex, the x or the y coordinate of my vertex then is going to be 0. So that is pretty juicy information right there that we know what that exactly is going to be. So we already said that this is going to go ahead, this is going to have a minimum value because again the graph opens upward. We already went ahead, we found that vertex then to be 2, 0. And because we always like more points than what we need, let's go ahead then. I want to find the x-intercept and the y-intercept. All right. Well, looking at this, okay, we have a vertex of 0, 0. We said that when we set this then equal to 0, this gives me x squared minus 4x plus 4. We already said that was equal to being factorable. That made no sense. We already said that was factorable, which means then x equals 2. We get a multiplicity of 2 twice, which means the vertex is on the x-intercept, which means we only process the x-axis one time. So in other words, the graph is going to, come on screen, all right, look then something like this, in which it only kisses the x-axis at one particular point. Fortunately for us, everything always has a y-intercept, so all we have to do is plug in x equals 0. So this then gives me 0 squared minus 4 times 0 plus 4. Well, that's 4, so that's going to be then the point 0.04. So we have 2 points now. Let's go ahead, let's plug in a couple more. I'm going to plug f of 1, f of negative 1. Again, these are just random points to go ahead and pick to try and get us some additional points to be on the graph. So the 0.11 will be on there. Negative 1 squared minus 4 times negative 1 plus 4. That's going to be 1 plus 4 plus 4, which is 9. So that'll be the ordered pair then 1, 9. So now plenty of points to work with. All right. Oh, sorry, getting ahead of myself. Domain. Obviously, it's a parabola, so negative infinity to infinity. My range, since it opens upward, is going to be from my minimum all the way then up to infinity. Again, we are including that point. And then let's go ahead, let's plot this out. I have my y-intercept of 0, 4. Negative 1, 9 is literally off the chart. Okay. What are some of the other points I had? Sorry, I forgot. 1, 1 is on there. Okay. We have our vertex of 2, 0. Okay. Now, if you want, we can go ahead and get some more points if you would like. F of 3, that'll be 3 squared minus 4 times 3 plus 4. So 9 minus 12 plus 4, which is 1. So there's the ordered pair 3, 1. All right. And if you recognize this, Parabolas are symmetric, all right? So we have what's called an axis of symmetry. It always goes directly through the vertex, all right? And if you want to get the equation of a vertical line, x equals, oh, come on, does not like me today, okay? So my axis of symmetry is always through the vertex. Since it's a vertical line this time, it's going to be the x coordinate, so that's going to be x equals 2. All right. Let's erase that. It's a little much. Okay, so 3, 1. Yeah, that's the points. Had some fun. Okay. Let's erase that point. Okay. So 0.11. 3, 1. Okay. This point, so I guess it shifted up, disregard that. All right, so then from there, we can go ahead, play everybody's favorite game of connect the dots. And there we go. Fantastic. So again, if you have questions, feel free to go ahead and email me. I will gladly help you out. You can now go ahead and do section 3.3 homework.